Hey, welcome everybody to lesson number 2 of Unit 2. Today we're talking about solving systems of equations by substitution. The last lesson, lesson 1, was talking about solving systems graphically, and we saw what all the results looked like, but that was graphically. Now we're going to be doing this stuff algebraically. There's multiple methods to solving systems algebraically. We're going to be looking at 2 methods in this class. The first one is by substitution. The next lesson we're going to look at would be the elimination method. There's also a course when you get further in your math careers called linear algebra. They'll show you other ways of solving these as well, including things like matrices. Pretty useful. The more variables you have, the more difficult they get. So we're going to start off with some pretty easy ones in this class. Pre-calculus, watch out, you're going to step up to 3 variables or possibly even more. Alright, so let's look at substitution. Here are the steps for substitution. You might want to write these down. Your first step is to solve one equation for one variable. My little trick that I'm going to tell you right now, you want to look for a positive if possible and no coefficient. That would be the easiest one to solve for. For example, you see down here this y, it's positive, there's no coefficient. That's going to be the one that we're going to want to solve for. In this example, we don't have anything with a no coefficient, right? They all have some sort of coefficient in front, but maybe we'll choose one of these 3 positive ones to work with. Okay, so that's my my little hint for step 1. Step 2. We're going to substitute the result from step 1 into the other equation and solve. You'll see how that works when we get there. And step 3, we're going to substitute that found value into the either equation and solve for the remaining variable. This right here into either equation, I'm actually going to show you a different trick than this. I'm going to show you that you can actually use whatever you got up here from step 1. Pretty cool, easy tricks to do. Okay. Last thing we're going to mention is, if you remember, graphically, we had 3 solutions. That's still going to be true algebraically, but we need to know what they look like. Right? Graphically, if we had a solution, it was where those 2 lines intersected, and we got a coordinate pair. That's going to be the same here. If we have solutions, we'll get an answer for x, an answer for y. We'll put them into coordinate pairs. But what will the solutions look like if we have no solutions or infinite solutions? Remember, no solutions graphically was where they didn't intersect. They were not they were parallel, right? Algebraically, we're going to end up getting some sort of false statement, right? We'll end up with a number equaling some other number, something that's not true, like maybe 1 equals 3. Right? If we get something false, it's not going to work. There's no solutions. Infinite solutions, graphically, it was the same line. They lined up on top of each other, but there were infinitely many possible answers. What that will look like algebraically is we'll end up with a true statement of some number equaling itself. Most likely, you'll get 0 equaling 0. That's the one that's pretty popular here. Okay, that's a true statement, but we didn't solve for x or for y, so in that case, we have infinite numbers of solutions. Now, I'm going to give you a fair warning. The first problem that I set up here is pretty easy. It's going to jump up in difficulty for our second problem, and then who knows what these ones down here, if we'll even get solutions. But I just want to warn you, these are they're not the easiest problems, but I'm doing my best to give you a little bit of taste of everything with these. Okay? So let's start right here with problem number 1. Actually, you know what? I'm going to keep those instructions showing just for this first one. Okay, so we want to follow step 1, solve one equation for one variable. My trick to you, I said, let's look for one with no coefficient that's positive. That y right here, that fits it pretty well, right? No coefficient and it's positive. So to get it by itself, we're going to subtract 4x from both sides. That's going to give us y equals 31 minus 4x. Okay, so we have step 1 accomplished. Step 2, we're going to substitute that result into the other equation, and then we'll solve. So what I need to do is I need to take this piece right here, right, where y is equal to, and I'm going to replace it in the other equation where I see a y. So this 2x, and this minus 3, those are all good. I have to replace y with what it's equal to, 31 minus 4x. and then it's still equal to 19, right? All I did was take this one piece out and replace it. Some distribution is required for this. Negative 3 times 31 is negative 93. Negative 3 times negative 4x is positive 12x. That equals 19. We want to combine like terms. 2 and 12 is 14x minus 93. And now we can start solving. We'll add 93 to both sides. 14x equals 112. Divide by 14. And we get x equaling 8. So we got a number here, right? So far so good. We have what the x coordinate would be graphically. What we're going to do now is substitute the found value into either equation and solve for the remaining variable. If I plug in x to either one of these, we'll be left with a y that we can solve for. But even better, this right here, right, it's already telling me what y is equal to. If I replace the value of x in here, I'll just have to evaluate this and I'll get y's value. So that's all I'm going to do. I'm just going to replace 8 with x. So let's see, 31 minus 4 times 8 is 32. 31 minus 32 is negative 1. So we got an answer for both x and y. That would be the coordinate, right? 8, comma, negative 1. That is our solution set for that particular problem, right? And remember, these two lines would be graphed and they're going to cross each other at that particular coordinate. This next problem, if you want to write it down real quick, this is a little bit more difficult, right? Because we don't have an easy variable to solve for, right? All these variables have a coefficient. The one I'm not going to bother with is this negative 7, because I don't want a negative. I want to try to work with positives. We could choose any of these to solve for. I'm going to solve for this y up here. The first step would be subtracting 5x. So we would have, so I'll do this over here. We'd have 2y equals 16 minus 5x, and then we'll divide by 2. Yes, I'm still dividing individually. It's just a little bit easier for me to work with. 16 divided by 2 is 8. I'm going to leave that alone because it won't reduce. 5 over 2x. Not the easiest, happiest equation to work with, but we're going to do our best. If you have a calculator nearby, it will help you out. We're still going to take this and plug it in where we see a y. So we still have 3x minus 7, but we're going to replace now with 8 minus 5 over 2x. We still need to do our distribution. Negative 7 times 8 is negative 56. Negative 7 times 5 over 2, that's going to be positive 35 over 2x. This 3x, all right, we'll do it off to the side. I'll do it in a different color so you can see exactly what I'm talking about. This 3x, it's really over 1 right now. I need it to be over a 2, so if I multiply by 2 over 2, we get 6x over 2. So I'm making this really 6x over 2. Why? Because now I can combine like terms. That gives me 41x over 2 minus 56 equals negative 15. That was honestly, I think, the trickiest part right here was making sure that we combine those like terms properly and getting the correct value here. Now we can continue to solve. The solving isn't going to be much more difficult than what it already has been. I need to multiply by 2, and then we'll divide by 41. We get x equaling 2. Now, if I plug in here, wherever I see an x, I'll get my y. So I'm going to do that right over to the side. y equals 8 minus 5 over 2. I'm plugging in 2. Divide by 2 and multiply by 2. Those are going to eliminate, leaving me with 8 minus 5, which is 3. So we got a solution set here as well. A lot more work, a little bit more tricky with this fraction, but you know what? Most cases, in reality, they're not going to be the easiest. So we're going to have to make sure that we work through them. It's not a big deal. We got the problem all set. Okay, we have a few more that we're going to look at. If I remember correctly, these examples will show us no solutions and infinite solutions, I think. Let's hope. It would be pretty useful if they did. Going back to what we were just looking at, right? We don't have any easy variables to solve for here either, right? But I'm not going to bother with the y's because those are both negatives. So let's try solving for one of our x's. Let's try solving for this top x. All I have to do here would be add 3y to both sides. 2x equals 4 plus 3y, and then we'll divide by 2. That gives us x equals 2 plus 3 over 2y. All right, now we're going to plug in, right, substitute wherever we see an x in this equation, this stuff is going in. So the 6 stays, but the x gets replaced with 2 plus 3 over 2x. Minus 9y equals 12 is the same. I'm going to keep an eye on that for later. Here we'll distribute 12. Let's see, 6 times 3 is 18. Divided by 2 is 9. Oops, that's a y, not an x. I'm sorry. Y. Minus 9y equals 12. And now we can start combining like terms, right? My 9y and my minus 9y. Those will eliminate. And I get 12 equals 12. Oh, whoa, hold on a second. 12 equals 12. I got rid of my variables, right? There's no more variables. Now I look back at these options, right? What do we see here? Do we see a true statement or a false statement? I see a number equaling itself. That's true. That's matching with right here, right? A number equaling itself. That tells us that we have infinite solutions. I don't have to do any more work here because there's really no other thing for me to do here. It's not like, I mean, I could start listing possible solution sets, but there's an infinite number of them, so why bother? All right, let's look at this next example, and then we'll have a couple for you to try out. Again, let's look for an easy one to solve for. We could solve for either the y or the x. Let's solve. Let's go with the bottom one this time. Let's add 6y to both sides. That gives us 4x equals 10 plus 6y. We'll divide by 4. It gives us x equals 5 over 2 plus 3 over 2y. I'm just reducing what I can. All right, now we'll replace anywhere in this top equation where we see x. All right, so we've substituted this into this top equation. Now we need to make sure we do our distribution. Let's see, negative 2 times 5 is negative 10 divided by 2, that's negative 5. Negative 2 times 3 is negative 6 divided by 2 is negative 3y plus 3y equals 4. Combine like terms, negative 3y and positive 3y, those eliminate. That leaves me with negative 5 equals 4. All right, this is the other situation, right? Over here we had a true statement. Over here, this is not a true statement. -5 does not equal 4. That comes back to our option up here of no solutions, right? It's a false statement. We have no solutions to this problem. All right. So we've seen 2 problems with solution sets. Some of them are a lot easier. If it's nice and easy, you find a variable with no coefficient that's positive. It makes life easier. Sometimes they're more difficult, as we saw with these few. Sometimes fractions are involved. So, got a couple of problems for you to try out. Try these 2 first. Pause the video. We'll check those 2, and then I got one more afterwards for you to try. All right, let's see how you did. Hopefully, for this first problem, we wanted to solve for that little y down here because it's no coefficient, positive. So we'll subtract 3x from both sides. That gives us y equals -9 minus 3x. We'll replace in this equation. So 6x minus 2 times -9 minus 3x equals -6. You should have distributed here. -2 and -9 is +18. -2 and -3 is +6x. Combining like terms, we have 12x. And then we can start solving. I'll subtract 18. 12x equals -24, and then divide by 12. That gives us -2 for x. So far, hopefully you got that correct. If you didn't, check back through your work, see maybe where you made a mistake. Okay. Our final part, we're going to use this right here. Right, y equals -9 minus 3 times, we got -2 here. -3 and -2 is +6. -9 and +6 is -3. So we got 2 numbers, -2 and -3. That is our solution set for that first problem. You should have also done this second problem. Okay, so let's take a look at that one. Nothing easy to solve for to start with. So I would have picked one of these 2. In fact, I'm going to work with this top equation. I'm going to start by adding 2y to both sides. 3x equals 3 plus 2y, and then we'll divide by 3. So we get x equals, let's see, 1 plus 2 over 3y. Okay, I'm going to replace that down here wherever I see x. So 9 times 1 plus 2 over 3y minus 6y equals 2. We do our distribution. 9 times 1 is 9. 9 times 2 is 18. Divided by 3 is 6y. The rest of this stuff stays how it is. Combine our like terms are 6y and -6y. Those eliminate, and we end up with 9 equals 2. Uh-oh, that's a false statement. You should have said here, no solutions. Right? We didn't find an actual solution, and we didn't find anything that was a true statement. We found a false statement there. That's no solutions. You've got one more to try. Okay? Try that one last one. Pause the video, resume it when you're ready to check. Alright, let's see how you did. This is it, the last one. What did you decide to solve for here? I'm going to go for this positive 3x. To do that, I'm going to add 5y to both sides. So 3x equals -14 plus 5y. Divide by 3. Ooh, this was ugly looking. Oh well. Do what we can, I guess. So we get x equals negative 14 over 3 plus 5 over 3y. Oh, that's not happy looking, but we'll have to deal with it. Alright, I'm replacing x in this top equation. Now we'll do our distribution. Okay, negative 2 times negative 14 is positive 28 over 3. Negative 2 times 5 is negative 10 over 3. Let's see, if I want to combine like terms, I'm going to have to do a little bit of side work for this. Right, let's see, 6y over 1, I need it to be over 3, so that's 18 over 3y. 18 over 3y, and that equals 12. Okay, let's see, combine our like terms. 28 over 3 doesn't combine with anything yet. Negative 10 and positive 18 is positive 8 over 3y. Alright. Let's multiply everything by 3 to clear out this. Alright, if I do that, all that stuff goes away. Multiply by 3 here. So let's see, we get 28 plus 8y equals, let's see, 12 times 3 is 36. Subtract 28. 8y equals, let's see, that would be 8 divided by 8. We get y equals 1. That's good news. That was a lot of work, difficult work. You might have done something different, but hopefully you found y to be 1 there, or at some point. We're just going to replace in here, and we should get our answer for x. X equals negative 14 over 3 plus 5 over 3 times 1. Okay. Well, anything times 1, that's going to stay the same. So negative 14 plus 5, that would be negative 9 over 3, which would be negative 3. Now, the way that you should have written your solution for this, you want your x to come first and your y second. Okay, these problems were definitely more difficult, I think, than what you would be seeing on your class worksheet or the homework. They're a little bit more difficult, without a doubt. But I wanted to give you guys a taste of how to deal with different situations. Hopefully, you look for the easy variables first. Remember, that would be the variable with no coefficient, that's positive. Remember, every time I looked for on these problems, it had a positive coefficient. Keep in mind what your solutions will look like. False statements means you have no solutions. A true statement, but getting rid of all of your variables, that would be infinite many. And then finally, if you find your x and y coordinates, make sure they're written in coordinate pair. The next method, I think you guys are going to like a lot more than this. People generally do like the elimination method, but the good news is this. You get to choose which method you want to if it says to just solve. However, make sure you read those instructions. If it tells you which method, substitution or elimination, or graphing for that matter, you make sure you use that method. Okay, and we're going to check out that next method on the next video, and I will see you there at lesson number 3.